Today, we are diving into one of the biggest questions in modern medicine. How on earth can we trust a machine, an AI, with something as critical as reading an X-ray? Well, the answer, believe it or not, comes from a very special kind of doctor, one who literally works in the dark.
I want you to picture this, a small, completely dark room. The only thing you can see is the eerie glow of an X-ray on a light box. A physician is sitting there, just staring at the shadowy image of a coal miner's lungs. And they're not looking for the obvious stuff, like a tumor. No, they're listening for something much, much fainter. A story told by tiny particles. They're listening to the voice of dust.
So, who is this specialist who can do something that even our most powerful AI finds incredibly difficult? Well, let's pull back the curtain. They're called a B reader.
Now, a B reader isn't just any radiologist. These are highly trained experts with a special certification from the U.S. National Institute for Occupational Safety and Health, or NIOSH. Their one specific job is to use a globally standardized system, the ILO classification, to spot the super subtle signs of lung diseases caused by inhaling things like coal dust or asbestos.
And you have to understand, what a B reader says has huge consequences that go way beyond the hospital. Their finding can be the deciding factor in a workers' compensation lawsuit. It can determine whether a family gets a financial payout. Their data even helps shape national safety policies for entire industries. And for a patient, their reading is often the final definitive answer they've been waiting for.
Okay, so we have this incredibly trusted human expert. But now, we've got AI that is getting ridiculously good at reading medical images. And this sets up this fascinating conflict, a real paradox right at the heart of medicine today.
You see the headlines all the time, right? An AI can analyze an X-ray in seconds with over 90% accuracy. I mean, on paper, that sounds incredible. But when you actually talk to doctors, there's this real hesitation. So what gives? If the machine is so good, why aren't we just plugging it in everywhere?
This really gets to the core of it. There's a massive difference between technical accuracy and system trustworthiness. See, accuracy is just a number you get from a lab based on a specific set of training data. Trustworthiness? That's a human feeling. It's our belief that a system is reliable, that it's transparent, and that it's accountable when something goes wrong. An AI can be accurate without being trustworthy at all.
So how do we build that trust in a machine? Well, what if I told you the answer is right in front of us? We can actually use the exact system we built for our most trusted human experts, the B readers, as a blueprint for AI.
See, here's the secret. We don't trust a B reader just because they're a smart doctor. We trust them because they operate inside a very strict, very transparent, and verifiable system. The trust is in the architecture, not just the individual. And that is a lesson we can apply directly to AI.
And just look at what that system involves. First, there's a standardized method. Everyone plays by the same rulebook. Second, you have to pass a really tough certification exam. Third, there's constant auditing. You have to get recertified every 4 years to prove you're still on top of your game. And finally, your findings have real legal weight. It's a whole package designed to create trust.
So let's do it. Let's take this human blueprint and see how we can use it to build an AI we can actually count on. We can literally create a parallel system for machines that mirrors the one we already trust for people.
Check this out. It's a one-to-one match. A B reader has to pass that NIOSH exam, while an AI should have to pass a tough evaluation from the FDA or a medical college. A B reader gets recertified, and AI needs continuous monitoring even after it's on the market. A B reader follows strict guidelines, and AI has to be trained on top-quality data and be able to explain itself. And maybe most important of all, a B reader's finding has legal power, and AI's output must always be reviewed and signed off by a physician who has the final say.
Now, this isn't just some cool idea on a whiteboard. This exact model is being put into practice right now. And one of the most exciting examples in the world is happening in Thailand.
So the first step was a global one. The World Health Organization, the WHO, created something called a Target Product Profile, or TPP. You can just think of it as a set of minimum requirements, like a job description, for any AI that wants to be used for screening a huge public health threat like tuberculosis.
The TPP lays out these clear, non-negotiable benchmarks. So for an AI to even be in the game for TB screening, it has to meet these minimums for sensitivity, which is how well it spots the disease, and specificity, which is how well it avoids false alarms. It's like a global pass-fail test.
But just clearing a minimum bar, that's not really enough to build deep, lasting trust. So in Thailand, the Royal College of Radiologists knew they had to do more.
They decided to create their own local gold standard for putting AI to the test.
And to create a gold standard, you need an undisputed panel of judges, a benchmark of human expertise that no one can argue with. And they found it by assembling a very special group, 6 NIOS-certified B-readers. These would be the ultimate arbiters.
So here's how they did it, and it's brilliant. They took an AI designed for TB screening and gave it a big set of X-rays. Then, the panel of 6 B-readers read the exact same images. The AI wasn't just graded against some simple right or wrong answer key. No, it was graded against the consensus of these world-class experts. The real question became, does the AI agree with the experts as often as the experts agree among themselves? That's a concept called external consistency, and it is the ultimate test of whether an AI really thinks like a doctor.
So when you put all this together, what does it really tell us about the future? It shows us a clear path forward. It points to a new kind of partnership, one where machines don't just show up and demand a seat at the table, they have to earn it first.
And at the end of the day, this is the main takeaway. Building AI we can trust isn't about trying to make something that's smarter than a doctor. It's about building tools that can pass the exact same rigorous, transparent, and demanding exams that we already require of our most respected human specialists. It's about earning trust, not just claiming accuracy.
So as we move forward, we've got to remember that this whole challenge isn't really technical. It's deeply human. The true measure of any medical AI won't be in its lines of code, but in our collective willingness to trust it. The question isn't, can it do the job anymore? The real question is, has it proven to us that it deserves to?